and then the MAC address. One best feature that a switch has is that it has the ability to set the frame specific to the destination. It has this what we call as a MAC address table. In the MAC address table, it maps the MAC address of the PC and to which port it is connected. Okay, so for example, this PC1, this is its MAC. The 66 is the MAC address of PC1 is connected to port 1. So, and then port 3 is PC2. Let's say this 68 here is this one. So, if in case PC1 will send a frame to PC2, S1 will check its MAC address table. It will check the destination MAC. And if there's an entry, like in this case, there is, it will only forward it to port 3. Okay? So, only PC2 will receive that frame. Not like in a hub, say let's say this is a hub. Usually a hub, what it does, it always sends it to all. It always uses broadcast. Well, because of that broadcast, there's collision, there's too much congestion. In a switch, somehow it lessens congestion because of this capability of having a MAC address table. Even small business type of a switch, like in CDR King, there's a MAC address table, so it's a standard. MAC address table is also known as a CAM, Content Addressable Memory. So how does this MAC address table built? Okay, it happens when, let's say, example, A is connected to 1, B is 2, C is 3, and D is 4. Okay, so let's have that scenario here. So let's say A will send data to D. Okay, a MAC address table is built the moment that the computer will send. So let's say A will send data. Okay, so what the switch will do is to, since there's no, since the MAC address table is still empty, so what the switch will do is to map the source MAC, like in this case is A, to its incoming port. So it has a common sense that, oh, hey, I receive a frame that has a source MAC address of A and it came from port 1. So therefore, A is in port 1. Okay? So then it will check the destination. The destination is D, but there's no D here. So what switch will do is to broadcast. Okay? So there are still instances, but not that often, that the switch will broadcast or send to all a frame. Okay? So let's say, okay, D already receives that, and let's say D will reply. Okay? It will send a frame going to A. So the moment that the switch receives that, so it sees the it will get the destination, the source, sorry, it will get the source MAC, and that is D. It will map it to its incoming port, which is 4. And then it will check the destination MAC, which is in this case is A. Okay? So, and then it will see in the MAC address table that A is in port 1. So what the switch will do is to only now forward it into port 1. Okay, that's how the MAC address table is being built. MAC address table is stored in the cache memory. It's temporary. So usually it aged out every 5 minutes. So there, I've explained how the MAC address table is being built. And we have this frame forwarding method. This is the manner of a switch to process the frame. So we have this store and forward. In store and forward, what the switch will do is to receive and process the entire frame. So the switch will read all of this content from the preamble to the MAC to the type length data in FCS. Okay? Good thing with store and forward is that there's error checking. Error checking is on the last part. Okay? The problem with store and forward is it has high latency, delay. Okay, it takes time for the switch to process the frame. Okay, that's the problem with store and forward. That's why they came up with cut through. In cut through, take note that what the switch only needs here is not the data. The switch do not care what the data content is, but the switch do care about the MAC, right? Because of the MAC address table. So in the cut through, specifically on the fast forward, what the switch will do is to only read the destination MAC address. Okay, once it's read, then it will automatically forward the frame. The good thing with this is it has low latency, much faster as compared to store and forward. The problem with store and forward is that there's too much error. Okay, because there's no error checking. It doesn't reach this point here. Okay, they came up with another method, fragment free. In fragment free this is like somewhere in the middle of fast forward and store and forward. Okay, there's a couple of error checking, but not all. Um, And the keyword here is it only reads the first 64 bytes, so somewhere here. There's a couple of error checking, but it's not, again, not all errors are being detected by the fragment free. Among these types of frame forwarding method, what is commonly used is store and forward. Okay, even for small business type of switches, they use, most of them uses store and forward. And then, um, these are means of switch to queue yung those frames. So, um, or store those frames received. So we have port base. In port base, the queue is in each port. Okay, queues are linked to specific incoming and outgoing port. With the shared memory, all frames received are being placed in a common buffer. Okay, all placed in a common buffer, and uh, from there they will treat a QoS mechanism. Example, the default is a first come first serve type, okay, of a mechanism. Uh, one feature that our switch has is this auto MDX. In auto MDX, is we don't mind with the cable. Take note that, let's say, if you were to connect PC to switch, we use straight through, right? So let's say you are to connect PC to switch and there are no straight through available, only crossover. If a switch has a auto MDX, you can use that. It will work. Okay, it will connect. Even if, again, you do not observe the cable type. So that's auto MDX. By default, it's enabled. Okay, if in case it is disabled, you just type MDX auto in the iOS. Okay. In other vendors, there's also an equivalent for this. I think they call it as auto detect cable type. In other vendors, not only on switches but even on routers, they have this kind of a feature. Again, it's something to do with cable types. So example, switch to switch, there's no crossover, only straight through available. You can use that again if there is an auto MDX feature in that switch. As a summary for this chapter, Ethernet operates in the data link layer and physical layer. Ethernet standards define both the layer 2 protocols and the layer 1 technologies. Ethernet uses the LLC and MAC sublayer of the data link layer to operate. The Ethernet frame fields are preamble and start frame delimiter, destination MAC address, source MAC address, ether type, data, and FCS. MAC address provides a method for a device identification at the data link layer of the OSI model. An Ethernet MAC address is a 48-bit address expressed using 12 hexadecimal digits or 6 bytes. And when a device is forwarding a message to an Ethernet network, the Ethernet header includes a source and destination MAC address. And in Ethernet, different MAC addresses are used for layer 2 unicast, broadcast, and multicast communications. So this ends this last part. Okay. Thank you. Keep safe. Together we learn as one.